My name is Catherine, and today I want to explore how STEM can connect to some of our favorite books. Here's some background on the book 20,000 Leagues Under the Sea. The book was written by Jules Verne in 1870, and a league is meant to measure the equivalent of about 3 miles. The book is about characters Professor Pierre Aronnax, his servant Conseil, and Canadian whaler Ned Land searching for what is believed to be a sea creature of gigantic proportions that has been traveling through the seas at alarming speeds. Later, the three are washed up on the ship and embark on a great journey around the world. Here is the scene. Part 1, Chapter 7. Professor Pierre Aronnax, Conseil, and Ned Land, after they are thrown overboard their ship by retaliating attacks of the creature, they seek refuge on top of it, and as they are washed up, they realize that it is no creature. The surface is made of a steel plate. But they have no choice but to stay there. They are in the middle of the sea, with nowhere else to go. So the big question here is, how can a large steel ship even float in the sea? So a good way to think about buoyancy is if you imagine a U shape that has water inside of it. So if you fill one side of that container, then it displaces the water by the same amount that was taken up by this new object. It is similar in the sea, except that it's not quite as visual, because even though the sea is elevated, it is distributed across such a large, vast amount of water that you can't tell. However, it's the same concept. If the object is more dense, then it will sink because the potential energy will lower by the object going down. But if it is less dense, it will float because potential energy will lower by the object going up. So, how was the ship designed to balance equilibrium with the water? Submerging. When the weight of the ship is equal to the amount of water it is displacing, then it will be completely submerged. Tanks in the ship regulate whether the ship is submerged by filling with water or not, consequently displacing volume. 9/10. The captain in the book wanted the ship to be 9/10 submerged at equilibrium, so he calculated the weight so that it would displace 9/10 of its volume. This means that when it is floating, 1/10 of it will be out of the water. So, how is it supposed to dive? If the ship wishes to reach a depth of, for example, 1,000 meters, the ship will have to displace more tons of water than before. The ship has to then increase its weight, using auxiliary tanks to fill with water. To resurface, the ship has to expel the water in its auxiliary tanks to reach the original weight that causes 1/10 of the ship's volume to be out of the water. So many discoveries are left to be found, whether they be amazing new sea creatures or astounding scientific inventions. How can books and art inspire scientists to push the limits of their imagination and search for new advances? It has been over a century since this book was written. What more will we imagine, and what more shall we write? For more information, here are the sources that I used. Thank you.